Okay, philosophy class, here's a little help on your homework. I'm going to go through all the homework problems. Highly suggest you do the homework problems first. Don't come to this first and so you think you're going to learn it all here. You want to go through the practice first and then check your answers. So what I'm going to be doing here is just going through all the truth tables. Here are my rules that I have for ones and zeros. And the first thing you do in a truth table, of course, is to assign all the truth values, all the possible truth values for these things. And if you have three variables, and I do, P, Q, and R, if you have three variables, you're going to have 8 different columns. That is statistics there. I'm not teaching you statistics, but if you'd like to, I could definitely show you in class how that works. But yeah, this ain't a math class. Maybe I shouldn't show you in class because maybe I'm going to mess it up. So these are the options, right? If P and Q are both true, then either R can be true or false. Right, so here's a 0. That's supposed to be a 0. If P is true and Q is false, then R could be either true or false. And these are just all the options. And notice the variables maintain the same truth value throughout the equation that you're working on. So all the P's, the top half of the P's are 1s, the bottom half are 0s. Same here, top half are the 1s and the bottom half are 0s. Q, you can see, matches up exactly. R, I'm going to match up to 1 0 1 0 like that. Okay. Now for all these are if-then statements, and this is what we're going to. Ooh, jeez. Erase that. This is number 4 is what we're going to be worried about right here. That's the rule we're going to be working on for all of these. And what 4 says is this if-then statement is 1 equals, is true if either the A is false or the B is true. So if either A is 0 or B is 1. Otherwise it's just 0. So when I look through all of these things, the first ones are going to be the A's and the second ones are going to be the B's, just like this, right? And I'll be looking at them individually, right? So this I'm going to apply first these rules, the 4 rules. First I'll apply them to this, then I'll apply them to this. I look at my rule, and wherever A equals 0, this thing is going to be equal 1. So here are my A column with zeros. This is where all these equal 1. And when the B equals 1. So here's the two B equals 1s. 1, 1. Otherwise it's 0. So these two things are 0. Now over here, I'll apply the same rule to this one individually. This is going to be 1 wherever A equals 0. Let's see, here's where A equals 0 in this one. Or wherever B equals 1. Here's where B equals 1 in this one. And these are the places where either one of those holds, so they get zeros. And then for this one, again, apply the same rule to this one. Wherever A equals 0, here are the places where A equals 0. Wherever B equals 1 are here, these places right here. So 0, 0, and the rest. Okay, now you'll be worried about looking at the connectives here. So this right here is the truth value for this whole thing. This right here is the truth value for this whole premise over here. And this right here, of course, is the truth value for the conclusion. So I will see is there any place where these premises all are true and this conclusion is false. If so, then this is invalid. If not, then this is valid. So these are both true, but this is true too. Good. Alright, that's not a problem for me. One of these premises is false. Don't worry about that. Good. I don't have to. Remember, both premises have to be. All the premises have to be true, and the conclusion false. But not all the premises are true here, so I don't need to worry about that. Here, same thing. I'm good there. Here, 1, 1, 1. Both the premises are true, but the conclusion is also true. Good. Here, the premise is false, so I don't worry about that. Good. Here, the premises are both true on both of these ones, and the conclusion is true on both of these, so it's both true. This is a valid argument. Alright, same thing here. I'm going to be using rule number 4 for these. I have to divvy out my 1s and 0s first. It doesn't really matter which way you put the 1s and the 0s out, but to keep it straight, I always do it the same way. I always do 4 ones, 4 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros, and 1 1 0 0 or 1 0 1 0 for the R's. But it'll look different based on how many variables you have. Whatever you do, it's best to keep it consistent. So here I'm applying all of my truth values. This takes a long time, I apologize. Probably super fun to watch this. This is an amazing video. I apologize also for the background noises. I know that this isn't the quietest place. Alright, so here we will use this and apply it to both of these first. Wherever the A equals 0, here's where the A equals 0, these equal 1. Wherever the B equals 1, these places, these are 1, 1. Rest are zeros. Same thing here, wherever the A equals 0, right here, right here, right here, right here. Wherever the B equals 1, the rest of these are zeros. Maybe I should use like a highlighter to so this is the one you're worried about right here. And this is the one you're worried about right here. Alright, now, when you came to this one, you probably wondered, okay, now which one do I do first? When you're doing these truth tables, you always work on the inside out. Because you're worried about, is this thing true? And then you can worry about this thing as it relates to this thing. But if you don't know if this A over here is true, then you won't know if A then B is true. So first you have to deal with this. And this rule is right here. This equals 1 if either one of these guys equal 1. So if this one equals 1, then wherever this one equals 1, this one equals 1. If this one equals 1, wherever it equals 1, this one equals 1. Neither one of them equal 1 here, so this is a 0. Neither one of them equal 1 here, this is a 0. Alright, so now I'm worried about, I'm looking at this as my A. Right here is my A, and right here is my B. Okay, so I'm going to apply this rule right here to this. Wherever A equals 0, which is right here, this equals 1. Wherever B equals 1, which is right here, and this equals 1. Here's a place where A equals 1 and this B equals 0, so 0, 0, 0. And again, I'll bust out the highlighter. There it is right there. That's the one you're worried about. So we're looking, can the conclusions be true and the premises be true and the conclusion false? Here the premises are true, the conclusion is true. Good. Premises true, conclusion true. Good. Premises false, don't worry about it. Premises false. Premises true, conclusions true. Good. Premises true, conclusion true. Good. Premises false here. Premises true, conclusions true. Sweet. Valid. This is a valid argument. Oh lordy. Alright, this just keeps coming. Oh, this isn't enough. I'm out 1. That's okay. I'll add it down here. So, same exciting thing that I did before. You can see why people would love to be logicians. Who doesn't want to assign truth values? Actually, the fact that this is so long can show you exactly why tomorrow we're going to do what we're going to do. Tomorrow's going to be so much easier. It's going to be so much prettier than these long ones and zeros. 1 1 1 0 0 0. Okay, so I've assigned all my truth values. Now remember, when you get to this one, inside out first, right? This is going to be A, and this whole thing is going to be B, right? This whole thing in this. So first you have to figure out what are the truth values here. Now the AND sign works right like this. It's 1 if both of them are 1. So like this, both of them are 1, and it's 0 otherwise. So here, not both of them are 1, so this is a 0. Same thing here, not both of them are 1. Both of these are 0, so there's a 0. Here, both of them are 1, so we're good here. 0, 0, 0. Alright, now to this one. If P then Q, right? If A then B. it is the rule right here, if a equals 0, so here I have a bunch of a's equal to 0, or if b equals 1, here's b equals 1, and b doesn't equal 1 otherwise, so the rest are zeros. So this is the column I'm worried about, right? That's the whole thing is an if a then b statement, and then this is the truth value right here. Ooh, there's 11 instead. Oh, doggone it. Alright, well, jeez. That hurts, that hurts. Let's see here. I'll try to recreate this from memory. I'll do it like this. Alright, so we had this. I'll start applying the rules to these guys over here, and then I'll figure it out over there in a second. But I'm not going back because there's no way I can subject myself to that kind of abuse again. Alright, now for the not rule, I use the not rule over here if a equals 0, then not a equals 1, otherwise it's 0. So in other words, what not does is just flipping the switch, right? If p is true, then not p is false. And if p is false, then not p is true. Same thing for the r's over here, right? So I'm just flipping the switch. If r is true, then not r is false, and vice versa. Okay, so there we go. I know this is 0 from this is 0, and I think Q's what they went like this: 1 1 0 0 0 0. So this is a 0. This would be a 1. This is a 0, and this would be a 1. And that would make, let's see, these are all like this. Alright, and this is 0 0 0 1 1 1 1, like that. Okay, so this is what we already had before. Let me use my highlighter again to show you this is what I'm worried about here. This is what I'm worried about for these two, because it's not r. It doesn't say r by itself, it says not r. So that's the truth value I'm concerned about. So again, I'm going to be looking at, can this premise be true, and this premise be true, and this conclusion false? Well, here I have a false premise, so that one I don't need to worry about. False premise, false premise, false premise, not worried. False premise, true premises, true conclusion, good. False premise, true premises, true conclusion, this is valid too. Oh, there's that guy. Wait. Alright, so next one. If P then Q, then Q, then Q. Right? So first you have to go inside out. Now on this one, this is a little bit different because we don't have any premises. So we're not looking for can the premises be true and the conclusion false. We're looking, since the premises are always true because there are no premises, and we're looking, can the conclusion ever be false? So let's assign our truth values 1s and 0s. 0 1 0. Alright, and then we'll apply our for rule here first. 1 1, right, if a equals 0, or if b equals 1, so this is a false one. So then now I'm looking at this truth value and this truth value here, right? This right here becomes the a, and this thing becomes the b. So if a equals 0 here, or b equals 1 here, here, and then this is a 0 right here. So now this becomes the a, and this becomes the b. Alright, wherever a equals 0, here's where a equals 0. Oh, whoops, no, I'm looking at this right here. Sorry, it's confusing, huh? Eraser, I'm not going to erase all on the side this time. Yeah, so I'm looking at this right here. Here is where a equals 0, good. Here's where b equals 1, good, good. And here's the 0. So this is what I'm looking at. Is there any time where this can be false? Yep, right here. So this is an invalid argument. Alright, last one. Do the same thing, divvy out the ones and zeros. One, zero, oops, no, that's 1, 1, 0. And 1, 0, 1, 0, 1, 0, 1, 0. Okay, so first we're gonna have to work on inside stuff, right? And for this one, we'll do first. And every time a equals 0, this is going to be 1. Every time b equals 1, this is going to be 1. So here's the 0 right here. So this is this guy right here. This is its truth value. For this one, this is right here is the a, and this right here is the b. So you're going to have to do this first, all right? And remember, this was just flipping the switch. And then now we can apply the if-then rule to this one, and we can say every time a equals 0 right here, every time b equals 1 here, otherwise it's 0. So this is the truth value to this one. So we have truth value here, and then for this one, of course, we have to flip switch again, because it's saying if these things, then this is your b right here. This is b. So your b isn't q, it's not q. So you have to figure out what not q is. So I'll flip the switch on these guys, and here's what you're worried about for the conclusion. Now I have, this is still I'm sorry, for the end of this if-then statement. Now I have these parentheses out here, and I have this a, and I have this b. Now I have to find this if-then statement. By the way, the quiz is not going to be anywhere close to this hard. So again, apply this rule here. I have a equals 0 here, b equals 1 here and here, and so the only place where a equals 0 is right here. So now this will become my a, and this will become my b. Wherever a equals 0 right here. Wherever b equals 1 right here. 0, 0. So this is the if-then statement. I have 0, 1, 0, 1. So I have two places where this could be false. So this also is invalid. That's the practice. Please feel free to email me if you have any questions. Otherwise, I will talk to you tomorrow.